Good morning, this is Ms. Gonzalez. Today's videos are going to be continuing the key attributes of functions and going a little bit more deeper into different ways we can describe functions. So this first video is all about continuity. Continuity is a big topic in calculus. So for any of you taking calculus next year, possibly in college, continuity is one of the most important aspects of calculus. It kind of builds off of continuity. Every topic kind of goes back to continuity and describing the graphs in terms of its continuity. So this is a big concept to grasp, okay? So up until now in Algebra 2, you are usually used to everything being continuous, or possibly this jump discontinuity we talked about too. So these, all of here are the pictures of the different types. So you could have a graph that is continuous in all spots. You could have what's called a removable discontinuity. Both of these is just a hole in the graph. Now, a hole in the graph would come from possibly if I had a fraction, say, that's like a negative a. So let's say x plus 2 on the bottom and x plus 2 on the top. So when we talked about implied domain the other day, in our implied domain said that we can't have a 0 in the bottom. So x plus 2 cannot equal 0. Well, if you solve that, it means x can't equal negative 2. This would result in a hole. Now, the difference, the reason why it is just a hole is because when you look at this fraction, they're the exact. The numerator and the denominator is the same. So if you were to solve this, it becomes 1. So that's how you get a hole. You can also get a hole by a piecewise function. And so maybe where they met up, so I could have had a piecewise function which connected these two in a different way, like maybe at negative 2. So this was some type of function that was less than negative 2. And then this is some type of function that is bigger than negative 2. If you notice here, neither one of them are actually equal to 0. To negative 2, sorry. So neither of these examples would have been equal to negative 2, therefore giving you a hole at the graph because you don't have a value at that point. But with these two graphs, they would have to meet, okay? So this is called removable. Here you would have had the piecewise function that gave you that point as part of the function. So this one would give you the function, let's call that 4. So saying y equals 4 for x is equal to negative 2. Because this one has a point there. So this one would have been that. This graph here would have been the one that we would say is where both of them were less than negative 2 and greater than negative 2 with nothing being equal, because nowhere on that graph do we have an equal. Okay, so that's one type of example, but again, the graph would have to meet. Here, this is jump. So if you look here, it jumps. There is that big space, which is why it's called a jump. This is most piecewise functions. There's a test that when we get to piecewise functions, we'll actually look a little bit deeper into it. For now, you'll just be looking at graphs and deciding the continuity. But later, we'll look at it, that there's a test when you actually do piecewise functions to see, would it be connected? So when you graph the piecewise function, do the pieces overlap or do the pieces separate here? And this is why this is a jump, because there's that big gap right here. So that would be considered a jump. This is infinite discontinuity. These are what our next video is going to be. It has what's called an asymptote. So it's going to be similar to the function up by there, but maybe they didn't cancel. So an x plus 2 would result in this graph because they don't cancel. I can't be negative 2 again, and therefore I would have an asymptote. We're going to look more into asymptotes next unit and in next video. So next video we're going to describe it and see how to look at it. All of next unit, it's all about, this is called a rational function, and we're going to look at rational functions and their attributes. So this is continuity. If you have any questions, please ask. You have the next one to identify which one. just to go back and make sure you understood. The reason it's removable is because I could color this in one spot, and now it's connected. I could color in here, and now it's connected. There is no way here to color this in. This is not coloring in and making that make sense. That's a vertical line. Vertical lines don't make sense. So that wouldn't be something that we would be able to do. But for those, if you want to know if it's removable or not, you look, could you color it in without changing the problem too much? And that's why it is removable.